Welcome to the 12.2 video. We are going to do a continuation of the 12.1 in the sense that we finished off by graphing just certain pieces of the function, and now we're going to write the function and then also graph piecewise functions. And piecewise functions are exactly what they sound like. They're pieces of a function. Okay? So first of all, look at the graph and write the equation of the function. So this is going to be a horizontal line. Remember Hoy-Buck, so this is y equals 3. And then put a little comma, and then when do we want x? Well, first of all, it's going to be greater than or equal to. And then make sure that you put the equal to sign underneath since it's a closed circle to 7. That's it. Okay, let's take a look at example 2. And the first thing we're going to do is write the function. So we have y is equal to, it's a negative slope since it's falling to the right, and then it's going to be a negative slope of 3 over 2. Notice that if I start at my endpoint, I go up 3 over 2, up 3 over 2, and then look for the y-intercept, which is going to be minus 1, and then we put our comma for when we want x. And in this case, we just want when x is less than 2. So it's an open circle, and we only have things to the left, so left for less than. Okay. Notice that there are 2 endpoints in this graph, so we're going to have a start and a finish. So first, once again, write the equation. So y equals negative 5, comma. And then where does the function start in terms of x? That's going to be negative 3 less than or equal to x, which is less than 6. Remember that the Sharky Mouse need to go the same direction, and we have 2 due to the fact that there's 2 endpoints. Okay, go ahead and try the next one on your own, so hit pause and then check when you're done. Okay, so here's what you should have gotten. So write the function first. So we have the y-intercept is 4, and then my slope is up 1 over 3, up 1 over 3, up 1 over 3. And then you write the function in terms of x, so that might be a good active note to take. And so we start at negative 3, and we stop at 6. So always write this in terms of x. All right, let's take a look at the next page. So this is actually a piecewise function. And as you can see in the definition, it says is several functions pieced together by using domain restrictions. So what we've only been doing so far is one piece. Now there's going to be 2 pieces, or 3 or 4. Okay, so first of all, let's just understand when we're supposed to use each piece. So it says find when f is negative 4. So you go to x equals negative 4. And you go up and you notice that the y value is 2. Okay. But then when you do f of 8, notice that it's a different piece. So the answer is 7. Okay. And then the last part is, notice that you are trying to find x. Remember, it says solve for x, and your answer should be x equals something. So draw that horizontal line at 4 and see where it crosses the graph. So x equals 5. Okay, and then we will practice writing the piecewise function on the next example. So let's go ahead. So we have f of negative 8. So we go to negative 8, and that's going to be negative 4. Then we have f of negative 3. So we're still on this piece, and we can actually figure that what that is because the slope is going down by 1 over 2. So that's going to be a half. So negative 3 over 2. And then f of 0. So this is the tricky one. Notice that there are two circles on f of 0. You pick the one that is closed. So when you're, sorry that I keep doing that. When you're evaluating, you pick the one that is closed. So we're going to stay on this piece, and the answer is 0. And then when we go to 7, we actually flip pieces, and that's going to be 3. Okay. And then it says solve for x when f of x equals -2. So let's draw that line. We're going to be on that bottom piece. So x, remember if it says solve for x, and your answer should be x equals something, -4. And then it says solve for x if x is equal to 3. So notice that it's this entire function that is going to be, if we draw that horizontal line, so we're just going to write the domain restriction to go along with it. So this is going to be x is greater than 0. Because at x equals 1 equals 3, at x equals 8 it equals 3, and so forth. All right, so let's write these two functions. We're going to do the one on the left first. So we're going to do, I'm going to write this in red. Okay, so the slope is 1/2. Okay. And the y-intercept is 0, so I don't need to include anything. I'm going to put my little comma, and then I'm going to say when x is less than or equal to 0. So notice that we only want this function for when x is less than or equal to 0. And then when we write the next function, we want it for only when it's greater than 0. So then my next function is going to be y equals 3 for when x is greater than 0. In order to be a function, we don't get too much into this in Algebra 1, but in order to be a function, you can't have you close circles in 2 spots. Okay? Close circle at the same x value, because then it would not be a function. That means basically that you have multiple birthdays, if you remember that analogy. All right, what I want you guys to do is go ahead and take a look at number 2. It's the same exact thing we just did, but it's with the graph, so I'll do one with you guys, and then if you can go ahead and try B and C on your own. Okay, so we want f of 1, so you look along here and decide where 1 falls, which would be right here, so your answer is 2. Okay. Go ahead and hit pause and do the next 2. Okay, so here's what we should have gotten. We should have got -5 for the first one. Oh no, I did not mean to do that. Okay, -5 for the first one. So when you want to find f of 2 when x equals 2, so you go over here and see which one that falls under. And since this is greater than or equal to, which means it's a closed circle, you use this function. Okay, and then for the other one, f of -3, so we go and we find where -3 falls under here, so it'd be less than 0, so use this function, and the negative's on the outside. Okay. Alrighty, let's get into graphing these now. Evaluating. Okay. So remember that this is just notation, so these are 3 separate pieces, and I'm going to use different colors to denote each separate piece. So we have piece 1, piece 2, and piece 3. Okay, and remember that these are just equations. So this really is y equals, and so forth. Y equals. So if y just equals a number, then that means it's going to be horizontal lines. Okay. So if we take a look at the first piece, so I'm going to use red. I'm going to start at -5, -6. So -5, -6. So I'm going to start this function at -6, -5. So I go to where x equals -6, I go down to -5. It's going to be an open circle. And then I want from x is less than -6, so I'm going to draw to the left. Okay. Then my next piece, which is the green piece, this has a start and a finish. So I'm going to go when x equals -6, go down to -2. This is going to be a closed circle because this is less than or equal to. And then I'm going to draw this line all the way over to when x equals 0, which is going to be an open circle. And then for my last piece, And I'm going to go ahead and start at when x equals 0. I'm going to go up to 3. It's going to be a closed circle because it is less than or equal to. And then I'm going to go over to 4 with an open circle and draw my line. So notice, this is kind of what I said on the previous page, how we should not have 2 closed circles here. Okay. And you only have arrows if there's not a start and a finish. So this is an example of a start and a finish. It has 2 endpoints, where the one above it only has 1 endpoint. So you should have an arrow since there's only 1 endpoint. All right, let's go to the next example. Okay, so once again, I'm going to do different colors for different functions. Okay, so I'm going to start at the endpoint for this function. So I'm going to plug in 2 into my function and I get 2 back out. So that is where I start, at 2, 2. Okay, and then since we want x is less than or equal to 2, I think it helps to write like left, right, or middle. So we want this piece just to the left because less than is to the left. And my slope is -1. So I need to make my slope fall to the right and then graph my line. Okay. And then for the blue graph, so make your XY table, plug in 2. Remember, it doesn't matter if it's an open or closed circle. And we get 5. So just at 2, 5, we're going to have an open circle. So 2, 5. And since x is greater than, I want to the right. Now this slope is 2, so I'm going to go up 2 to the right 1. So it's really important that you guys know how to graph slope, which hopefully we do by now. Okay, and a good active note to take here is your pieces should never overlap each other. So the only thing that can overlap are the endpoints, but they cannot both be closed circles, which we already addressed. So if I were accidentally drawn this green piece this way, my graph would have overlapped, and that's not possible because then it would not pass the vertical line test, which is what signifies if we have a function or not. Okay, so let's go ahead and go to example 3. And notice in example 3, we actually have 3 pieces. So I'm going to use 3 different colors. Okay, and I'm also going to write the whole left, center, right thing. So if x is less than or equal to -4, I want the piece to go to the left. If it's between 2 numbers, that means it's going to be in the center. And then x is greater than 2, so I want to graph this one to the right. Okay, so let's make an XY table for that first point. Okay, and we plug in -4, and we plug that into the red function that I highlighted, and we're going to get 1 as our answer. So we go to -4, 1. It's going to be an open circle. Now I want this graph to the left. So I have a slope of 1/4, so I'm going to go down 1 and to the left 4 so that it creates a positive slope. Okay. If you're still kind of unsure about that, remember you can always plug in another point. So let's say I plugged in -8, that is going to get me 0. And so that's how I get the next point. Okay. And then the green's a nice one because it's just horizontal line. So I go to -4, I go up to 2, close circle, go over to 2, close circle, and I just want the space in between. And then the last piece, I'm going to make an XY table. I'm going to plug in 2, and that's going to get me 4. Okay. So I plot 2, 4. Okay. It's going to be an open circle, and then I want this piece to the right. The slope is negative, so I'm going to go down 3 to the right 1. Okay. And then down 3 to the right 1. Sorry. Okay. And notice that my pieces never overlap besides at the endpoints, but there's never 2 closed circles at the endpoint. Okay. And then the last function we're going to do, notice that there is an absolute value function and a quadratic function, but we still address it the same way. And I'm going to write to the left since x is less than 0. And then this is the blue one, and it's going to go to the right. There is no center piece this time. So x, y, we plug in 0, we get 0, and it's going to be an open circle. I just want to the left. This is an absolute value function, so that's basically going to be half the v. My slope is 1 over 1. Okay. And then the one in the blue, so plug in 0. And it's okay that you have an open circle and a closed circle. This is a quadratic, so if you need to, plug in the numbers to figure out where your points go, or know the 1 and the 3. Okay. All right, we're going to go ahead and stop there for the day. Okay, there are a couple more examples on the next page, but I think that's enough for you guys to go ahead and start practicing. Thanks again for watching.